Hello, this is William Chung in Toronto, and welcome to World Ocean CO2, my app running in the cloud which lets you see world ocean CO2 trends over the last 50 plus years. You have two maps here. The top map divides the world into regions of 90 degrees latitude and 90 degrees longitude, while the bottom map divides the world into regions of 30 degrees latitude and 30 degrees longitude. How you use the maps is just click a region to see the CO2 trend in that region. For example, I'll click this region to see a graph of the ocean CO2 trends in that region from 1958 until 2010. For the bars, I use different colors to indicate the different CO2 levels that are measured in a given year. So I use blue for the average CO2 level, red for the maximum, orange for the minimum. And to provide context, I show the world CO2 land emissions in green. We can see that in 1958, the average CO2 level in this region, the ocean CO2 level, was 270 microatmospheres, and in 2010 the average went up to 367. So that was quite a jump over the last half century. And this graph also lets us see that in 2009 there was a spike in the CO2 level in this region. It went up to 840 microatmospheres. And we can also see that in 1986 there was a spike as well, where the CO2 level jumped to 822 microatmospheres. Let's go back to the home page. The bottom map, it lets you zero in on a specific region to see the CO2 levels more clearly. For example, I showed you this region. And now in the lower map, I can zero in on a subset of that region, like this one here, which I'll click. So we can see the CO2 level in that particular region, and this graph actually shows the comparison between the world land CO2 emissions in green compared to the ocean CO2 levels in this region very nicely. The other link here for the raw ocean CO2 data, this is for more for researchers. So this shows the raw data for each year when the data was collected. It shows for each year the number of samples collected, the minimum, maximum, average, and I use this raw data to build the graph. Let's go back to the home page. The other feature of this app is you can see the top 10 ocean CO2 hotspots. So let's click on that. And I use a red border around the region to indicate that it's a CO2 hotspot. And additionally, I use the thickness of the red border to indicate the ranking of that region in the hotspots. So these are the top 10 hotspots. And we can see because this region has the thickest red border that this is the number one hotspot. So the average in 2008, which was the last year where the data was collected in this region, the average was 503 microatmospheres. If we go back to the map, we can see that this region is number 2 based on the thickness of the red border, and the average was 500. So number 3 would be this one based on the border thickness, and the average 2008 was 455. So the top 3 now, which would be the 4th in the ranking, would be this one. and we can see that the average was 448 microatmospheres in 2010. This region had data collected more recently in 2010. So that's helpful in giving you like an overview of the hotspots at a glance in the global oceans. The data that I used for the Ocean CO2 data, I got that from the Carbon Dioxide Information Analysis Center, the CDIAC. So I can show you where I got the data. The data came from this data set here, which consists of 5.2 million measurements of the CO2 levels over the global oceans from 1957 onwards. So what I did was to take the 5.2 million measurements and group them into the regions of the world for my two maps here. And in each region, I calculated the minimum, maximum, and average values. For the world CO2 land emission data, I got that from the World Bank CO2 emissions indicator. One of the reasons why I developed this app is I wanted to I wanted the general public to have better access to the data. And what I mean by that is from the CDIAC on their website for the Ocean CO2, you can specify like a longitude and latitude and a time period, like from year and to an ending year, and specify which CO2 measurement you're interested in to plot a graph. And you can select on-screen plot here and run the query. But the issue with that, actually, this is not the results of that query, by the way. This shows all the ship routes for the ships that were used to collect the data since 1957. Now, when you run the query, it takes a little bit of time, and once you get the query back, the result is a plot like this. And this plot is useful for researchers and academics, but I think for the general public, this type of interface is more accessible. So for me in Toronto, in Canada, the closest part of the ocean to me is this region. I would just click on this region here, and I would see at a glance and quickly, I would see how the Ocean CO2 has been trending in that region closest to me over the last half century. And I could also see how that compares with world CO2 emissions. So I hope that you find value in this app, World Ocean CO2, and thank you.